What is the hjulstrom curve? It's basically a diagram that shows the relationship between the velocity of a river and the size of the particles that are either going to be eroded, transported and deposited. So now we're going to look at how to draw the hjulstrom curve. As you can see on screen now, it's basically a box set structure that has a pair of axes, and it also displays the type of pebbles that are going to be located inside the river. So on the x-axis we have the particle size in millimeters, and on the y-axis the average velocity. What I would like you to do now is pause the video and copy down this graph in case you do not have it, so that we can be ready to start explaining it. Now it's divided up into three areas, and the first of these three is called the transport zone. This is the area that is located under the entrainment velocity, the blue curve, and above the fall velocity, the yellow curve. Now entrainment velocity is the velocity needed to pick up the river's particles completely, and the yellow line is the fall velocity, which is the velocity needed to deposit the river's particles. This means that between these two zones we have the transport zone, which is basically moving along the particles down the river. Next up we have the deposition zone, and this is the zone pretty much where all the particles are needed to be deposited and left to one side in the river. So if the velocity is below the full velocity, this means that the particles are then becoming stationary and they're just going to be left at one point in the river where there isn't enough energy to then move them along. So they're not being transported and they're not being eroded. Therefore they're just deposited somewhere and they're not going to be touched. The last zone is the erosion zone, and this is located above the entrainment velocity. So at this point the river has so much energy that its particles can be picked up and they can begin to erode. So you may be thinking, why is it that these curves change shape depending on where they are on the graph? Now that's because up top we have all the different types of particles: clay, silt, sand, gravel and pebbles and boulders. Now some of these require more energy and less energy to be eroded, transported or deposited with. So we can clearly see that silt and sand do not need much energy at all to then be eroded with, and pebbles and boulders are the ones that require the most energy to be picked up.